Hi everyone, ABC is a triangle, and CD and AB are perpendicular to each other. AC and DB equal 5 units. AD is 1 unit. What is the length of BC, that is, x, in units? Now, let's start with this triangle, friends. Let's call this angle 90 degrees, and let's call this h. Let's apply the Pythagorean theorem here. The sum of the squares of the two legs will be equal to the square of the hypotenuse. So, 1 squared plus h squared equals 5 squared. From here, 1 plus h squared equals 25. Let's move the 1 to the other side as a negative. H squared equals 24. Let's also put this under a square root, guys. Let's do it like this. 24 is the product of 4 and 6. The 4 will come out of the square root as 2. So, our height, that is, our h, will be 2 root 6, friends. This part is 2 root 6. Now, let's apply the Pythagorean theorem again here, and let's show it like this. Again, the sum of the squares of the two legs will be equal to x squared, that is, the square of the hypotenuse. Let's start now. We'll say 5 squared plus 2 root 6 squared equals x squared. So, does it look clear enough? Yes, that's 25 from here. This square is both the square of 2 and the square of 6. 2 times 2 is 4. From here, we'll also get a 6. Let's say equals x squared. 25 plus 24 equals x squared. Where should I show this from here? I'll show it right here, guys. Look, I'm adding this part up. 49 equals x squared. Let's put it under the square root. From here, x equals 7. Hello, guys! We're going to look at a geometry question together. Let's get started. ABC is a right triangle, and they've shown the information on the question. They're asking us for the length of x. Okay, now friends, a perpendicular has been dropped from the right angle, right? So, I can solve this question using the Euclid theorem. How are we going to do it? Here, I left a little note for you about Euclid. I thought you might want to check it out. Now, I'm going to call this ch length y. Okay, friends? Look, I'm going to use the Euclid theorem. Let's start from here. The square of 4 root 3, friends, is equal to... Look, pay attention. I'm going to say y times y plus 2, okay? I said y times z plus 2, guys. Now, 4 times 4 is 16, and 16 times 3 is 48. So this part will be 48, friends. We got y times y plus 2. Now, guys, which two numbers multiply to 48? So I'm going to assign a suitable number here. Isn't the product of 6 and 8 just right? Great. So the value of y is 6. Now I know that this part is 6. Now I'm going to use Euclid again, okay? This time, I'm going to find x from this side. Let's get started. What are we doing? Where should I write x squared? I guess I can write it right here. X squared equals, friends. Now, pay attention. I'm going to multiply 2 by 6 and add 2. 2 times 8. 2 times 8. So x squared equals 16. Of course, you're going to take the square root, right? If you get rid of the square root, what do you get for x? The square root of 16 comes out as 4. So the length of x is 4 centimeters. That's it. Hi, guys. ABC is a triangle. They've shown all the information on the question. They're asking us for the area of ADC. In other words, they want the area of the big triangle. Okay. Now, friends, first we're going to start with triangle DCB. There's a 90-degree angle here and 60 here. So guys, angle B will be 30 degrees. As you can see, we have a special 30-60-90 triangle. I've left a note for you. I'm going to apply that note now. Guys, if the side opposite the 90-degree angle is 12, then the side opposite the 30-degree angle will be 6 units, okay? Now, we're still in the same triangle. If we drop another perpendicular from this right angle, so if I draw another height, let's do it like this. This will also be 90 degrees. This will also be 90 degrees. And let's call this point H. Okay. Now, pay attention again. There's a 60-degree angle and a 90-degree angle. So, the angle here will be 30 degrees. If the side opposite the 90-degree angle is 6, right? I'm applying the 30-60-90 special triangle again. If the side opposite the 90-degree angle is 6, then the side opposite the 30-degree angle will be half of 6. So, 3. The side opposite the 60-degree angle, friends, will be 3 root 3. Okay, that's all done too. Now look, this part is 3 centimeters. The whole thing was 12 centimeters. So that means there's 9 centimeters left here, or 9 units left. Okay, now pay attention to triangle ABC. We're moving on to the big triangle. Now, if these two sides are equal, friends, doesn't that make this an isosceles triangle? We drew an altitude in this isosceles triangle. Did you see that? The altitude you draw in an isosceles triangle creates a median. What does that mean? It means we've divided these sides into 2 equal parts. So, if this side is 9 centimeters, or 9 units, then this side will also be 9 units. Now, if this part is 3 centimeters, then how many centimeters are left here? 6 centimeters, friends. Now I know the base. My base is 9. From 9 it became 18. We know the base. We have the height. So now you can state the area. What do we do? Isn't it base times height? We say 3 root 3 divided by 2, friends. Now, I simplified 18 and 2. 9. I multiply 9 by 3. Our area will be 27 root 3, friends. That's it. Hello, friends. In triangle ABC, ED and BC are parallel to each other. A perpendicular is given to us. It's stated that the angles here are equal. The length of AB is 8 root 2 centimeters, and the length of BC is 18 root 2. They've asked us to find the length of ED. Okay, now guys, ED and BC are parallel to each other. Let's write down what's given. The length of AB is 8 root 2. The length of BC, guys, is 18 root 2. Okay, now let's do it like this. I see an angle bisector and I also see an altitude here. If I just complete this segment here, that is, if we draw the length EF like this together. Guys, let me put it this way. In a triangle, if a line segment is the same line segment, and it's both an angle bisector and an altitude, then this is an isosceles triangle, okay? Nice. So, this means that the length of AB and the length of EF are equal to each other. Guys, if this part is 8 root 2, then this part will also be 8 root 2. So, what was the total? It was 18 root 2, friends. So, what's left for here? 10 root 2, guys, awesome. Now, pay attention. They asked for the length of DE from me, right? Look, what happened? Let me put it this way. The vertex angle and the angle bisector are, at the same time, both the height, right, friends, and also the median. You know, since it's an isosceles triangle, that's nice. So, DE is the midline, and look, we also have parallel lines, which is great. This is the midline. How do you find this, guys? Well, by taking half of 10 root 2, so the length DE will be half of 10 root 2. If you simplify, it will be 5 root 2. Hello, everyone! Now, we're going to look at a geometry question. ADC is an isosceles triangle, and CA and CB are equal. These lengths are equal. AB and DC are also equal to each other. So let's show these as well. Nice. We're being asked what the value of x is in degrees. Okay, guys. Now, if this is an isosceles triangle and these two sides are equal, that means these two angles are also equal. So let's do it like this. Look, let's subtract 52 from 180. We'll get 128. These two angles, guys, will share 128 equally. When we divide by 2, each of them will be 64 degrees. Let's write it like this. Nice. The whole of this part is also 64. Now pay attention, guys. When we look at it like this, you see that AD and AB were also equal to each other. So this is also an isosceles triangle, isn't it? Then, if these two sides are equal, and this angle is 64 degrees, this angle will also be 64. The angles are equal to each other as well. Well, guys, it already looks like the previous triangle, doesn't it? Look, 64, 64, 128. So, what's left for here? 52, guys. Wasn't this whole part 64? Yes. So, when we subtract 52 from 64, the angle of x, let's write it like this. The degree of x, guys, will be 12 degrees.